today we're going to be looking at an introduction of probability and looking at multiple events. That'll make a bit more sense as we go and have a go at going through this topic. Before we do that, I would like to ask you, if you can go on slido.com, I want to ask you before we get started, how confident do you feel about the topics we're going to cover today so far? How confident do you feel with probability? I want to get a rough idea of where we're at so I can tailor the rest of today's session based on that. So if you're giving me fives, I'm assuming you have the basics, so I can kind of continue on from there. But if not, let me have a look. That was the thing. Okay, we've got 3 people answering so far. How many people are here? Let's have a look. We've got around 37. So I'm gonna wait till I see a lot more people responding to that. All right, so far, let's wait for a few more people. This is interesting. Some people are giving it 5s. However, it's a very varied response, so the average is actually quite low. Okay, so let's stop there. 27% of you have submitted your answers, and the average score is around 3.9. Okay, so I'll bear that in mind when I'm going through it, and hopefully at the end when I ask you this question, everyone will be giving 5s. So 3.9, that's something to compare to. So let's begin. Our learning objectives for the first part of our session, before we go on for our lunch break, is we're going to be looking at different types of frequency and probability and looking at differences between relative frequency and probability. We're going to look at relative frequency equals the formula. We're going to look at how we can describe probability using words, describing probability using numbers as well, and also calculating some estimates from some probability and looking at some outcomes, calculating a probability of an outcome occurring. And there will be a lot of content, a lot of words, a lot of things I'll be saying, so I do advise you having a piece of paper, pen and pencil at hand to make notes. As I say this every week, you need to get into the habit of when somebody's talking to be able to make notes. That's what you do at university. As I said, when I was at uni during physics, I used to have, when I was studying astrophysics, I used to have lecturers who didn't know how to use technology, so they never had PowerPoints for presentations. So for 2 hours straight, they would just be talking and we would just be making notes. So we've got the luxury of having the PowerPoint presentation, but make sure to take notes as we're going along. So relative frequency, what is relative frequency? Now, relative frequency is making an indication, making a kind of like a prediction of what might happen based on observation. So based on what we have seen, how often can this occur? How often can this subject, how often can this thing that we're measuring, what's the probability of this might happening? So that's what we call relative frequency, and there is a formula that we use to calculate this relative frequency, which is the frequency divided by the total frequency. Now remember, your answers can be written as a fraction, a decimal, or a percentage. So don't be puzzled as to why it's not a whole number. No, we would write this typically as a fraction, a decimal, or a percentage, so don't worry if you see them in a different format. So remember how often something might happen based on what we have seen. So let's have a look at an example of that. Here is a list of favourite cereals of Year 7s in Jenny's class. What is the relative frequency of Year 7s who like Cocoa Pops? So going back to the formula, we're looking at the frequency divided by the total frequency. That gives us the relative frequency. So if I've got 15 for the Cocoa Pops, that's the frequency. That's going to be divided by the total frequency. And what do I mean by total frequency? Well, total frequency is looking at how many people there are in this class that have said that they like cereal. So we calculate all the people, in this case 15 plus 9 plus 6 plus 3, which gives us 30. So when we calculate all of that, oh, hang on, that should be 30. Hang on, 9, 6, 6, 9. Oh, I think they've missed out one there. I think that should have been a 4. Oh, no. 9, 9, 18. I think they've missed out here because it says that 15 out of 30 year 7s liked Cocoa Pops. So I think it's either this should have totaled up 30 or there's been an error with the numbers here. I think that's the case. I think this should have been a 5 or something. And then the total of here, the total frequency would have been 30. And that's why they've said 30 here. If not, we're just going to have to do the total, which would be 9 and 9, 18. 18 plus 15, that gives us... Is that 18? Am I correct? Is my math correct? 8, 9, 6, 9, 9. Yeah, 9 plus 9 is 18, 18, 18, 3 there. Oh, hang on, that's 33. So 33. So I'm very confused as to how they got 30. So what we would have done here is you would have got 15 out of 33 because that would have been the total. And from that you would have done, you would have divided them as a fraction form because we're calculating the relative frequency. And from that we would be able to get the decimal or the percentage as 50%. Okay, but if I was looking at my other value, which I've got, when I add them all together, when I've got my relative frequency to equal 33, I'm going to do 15 divided by 33, so that gives me 0.33, sorry. And that should have been 0.454545. And so what I would say is that's around 0.45, which is the same as 45%. Okay, so that's how we would calculate the relative frequency. We've looked at the probability of that, how an indication of how often that Cocoa Pop occurs based on all the cereals that people have chosen. So between Cocoa Pops, Cheerios, Cornflakes, Weetabix, 15 out of those 33 had chosen Cocoa Pops. So 15 out of those 33, that gave us 45%. So 45% based on the observations of the children in the class. Let's have a look at the next part. Now, relative frequencies will always add up to 100% or 1. Okay, so we must remember this. This is a really important part, even for probability, for you to understand that it will always add up to 1 or 100%. So in this case, again, the mistake is here. This should be 33. So I've got here the total frequency of is equals 33. We've got to calculate the relative frequency for the other different types of cereals. So let's have a look. For Cheerios, what would it be? Well, it was simply based on the formula. We know it's the frequency divided by the total frequency. So the relative frequency is just simply going to be 9 out of 33. If I have a look at the cornflakes, we're looking at the frequency divided by the total frequency. So in this case, the frequency for cornflakes is 6 out of the total, which is 33. The Weetabix follows the same process. It's 3 for the frequency out of the total, which we go back to the 33. Now, if I want to write that as a decimal, because they've asked it for us, have a look here. It says relative frequency in decimals. All I'm going to do is I'm going to use my calculator and I'm going to divide them with each other, and I end up getting 0.27 for the first one. Then I have 6 divided by 33. I get a 0.18. Guys, remember, a fraction is the same as dividing, so don't be confused as to why I'm dividing. It's because fractions are division. And this equals 0.09. Okay, so here I have my answers given as a decimal. Now remember, at the bottom here it says here total. So what I'm going to do now is I'm going to have to take the total of my relative frequencies. So let's have a look. If I put them into, if I add them all together, I've got 0. Well, it's not 0.5, is it? 0.45 from what we calculated in the previous slide, plus 0.27, plus 0.18, plus 0.09. I end up with 0.99. Well, we know it should be a total of 1, shouldn't it? But because of the fact that there was an error there with this question, we have here 0.99, rounded to 1. If I had to look at the next column, it says here relative frequency in percentages. So now we've got to convert those decimals into a percentage, but we know that's quite straightforward because we know percentages is basically the fraction with 100 in the denominator position, and you just replace that fraction with a percentage sign. So in this case, 0.27, how would I write that as a fraction with 100 in the denominator? Well, that would be the same as 27 over 100. And that as a percentage, what did I say? Well, we're going to get rid of that 100 and just put the percentage sign next to it. So this one we've got 27. The next one I've got 0.18. Again, I'm going to convert that into a fraction with 100 in the decimal place. And so if I've got 100 here, what do I need to have in the numerator? Well, I know this number here is going to be 18 divided by 100. And that is the same as 18%. Okay. If I keep on going, I am left with these values here, and the total, if I was to add up all of them together, well, I should get 99%. Okay, so that's how we can calculate relative frequencies, writing it as a fraction in regards to something. So Jenny asked someone in year 7 class what their favorite cereal is. Based off her results, she predicts that they will most likely say Cocoa Pops. So based on this table, we can make a prediction, we can make an assumption based on our observation, okay? Because of the relative frequency, we can say that it's most likely for the students to prefer to say that they eat Cocoa Pops, because we can see the relative frequency in percentage is 50%. So most likely the students will pick Cocoa Pops. So based on these observations, based on the statistics, the probability that we've calculated, we can make a prediction. So we can make a prediction. If Jenny said, John in this class, what's the likelihood of John eating Cocoa Pops, Cheerios, cornflakes, or Weetabix, we can say it's most probably that John likes to eat Cocoa Pops because 50% of the class like Cocoa Pops, and that's a high probability of him liking Cocoa Pops than it is for him to like Weetabix. So that's how we use relative frequency in maths. Let's see if we can have a go at this Slido question. It says here, Dan records the colour of the cars in a car park. He records the total of 75 cars' colours. 15 of them are blue. What is the relative frequency of the blue cars? Have a go at this question on Slido. Let's see how many have joined now so I can look at when to stop. Oh, 50. Okay, now I've got to leave it on for a bit because at the moment it says only one person's submitted an answer. Got 27 people. Give it a couple more minutes. All right, let's stop there. Let's have a look. We've got 62%, 60% that says 0.2, 25, 0.25, 11%, 0.50. Okay, so this one, there is a clear winner, obviously, but it's not too far ahead from the others, but I guess the percentages are changing. So let's have a look and see how we would solve this question. It says here he records a total of 75 cars as colours. Okay, so there are 75 cars in the car park, and he's looking at the colours. Dan is just recording their colours. 15 of these cars are blue. So what will be the relative frequency? So we know to find relative frequency, we've got to look at the frequency of what we're looking for divided by the total frequency. So in this case, what are we looking for? Well, we're looking for the blue cars. So what are we going to do? We're going to write a fraction. In the numerator, we're going to have 15, and in the denominator, we're going to have 75. What happens when I write that as a fraction, and if I have to simplify it, well, that would be 15 over 75, and that would give us 0.2. So well done to the 85% of you that got that as 0.2. Okay, so let's look at relative frequency. Let's have a look now at probability. Now, the probability is the chance of something happening, and it's measuring how likely it is to take place. Again, similar to relative frequency, it's written as a decimal, a fraction, or a percentage. Okay. This formula, I recommend writing it down as the years go by. When you go into A-level, when you go into university, this formula stays, but perhaps you might see some symbols that replace those words, and perhaps there are some different wordings of it, but the concept stays the same. The probability of an event is equal to the number of ways that event can happen divided by the total possible outcomes. So if we have a look at the previous question, we were calculating the relative frequency for the cars, the blue cars. Let's have a look at this. What is the probability that that the next car that comes into the car park would be a blue car? So what we would do is we would look at the number of ways that event can happen. We'll calculate that and the total possible outcomes. How many total possible cars could we have, and what are the selection of colours that there could be? And from that, we've created the probability of measuring how likely it is for a blue car to be the next car that comes into the car park. So that is how we normally use probability. Like I said, make sure to write that formula down. Let's have a look at a bit more simpler example when we're looking at a coin. And I'm pretty sure you've done this question similar to this in your classes at school, where it says when you flip a coin, it's either going to land heads or tails. Okay, so we've got two possible outcomes. So if we had a go at using a probability question where we said, what is the probability of landing a heads or a tails, because they would be the same, what would it be? Well, the probability of getting a head, let's use this formula. Probability of let's do tails. I'm going to put T for tails, is the same as, well, we know the numerator is number of ways that events can happen and the total possible outcomes. Well, let's do the total possible outcomes first. So if we've got a coin, we've either got a heads or a tail. So how many possible outcomes do we have? We've got heads and a tail. Well, that shows us we only have two possible outcomes. And from those two possible outcomes, which one of these outcomes would be a tail? Well, we know one of them is a head and one of them is a tail. So one of them is the chance of that tail happening. So we have now calculated the probability of that tail occurring. We've quite simply said the probability is going to be the number of ways that tail can come up, which is only once because it's only heads or tails. So the total is going to be 2. So I can either write that as a fraction, as they've done here, or we can write it as a decimal or a percentage, because remember, for probability, we can show it in either way. Okay, or if you wanted to write it in a worded form, sometimes they do in your exam ask for a worded form, you can say there's an even chance, a 50-50% chance of this happening, of this event occurring. So let's go in a bit more detail about how we can describe probability using words. Now, we might say something like likely, very unlikely, impossible, even chance, and we probably use this in our everyday vocabulary, and we're not really aware that we're actually using probability. This is using worded probability. So, for example, now we can see the lovely sunshine outside London. It's quite likely for it to rain because we're living in London and it's been raining all week. So we can say it is possible, it is likely for it to rain in the afternoon. Or if we're basing on the weather forecast, we can say it's very unlikely for it to rain because it is now summertime and the weather forecasts, based on their probability and their prediction, have said that it won't be raining. Or we can say there's an even chance of it raining today in London. It depends on how the weather is feeling at the moment. So we can use words to describe probability, to describe an event happening. For example, it's certain that tomorrow will be Sunday. That is a fact. It's certain that that can happen. It is impossible for tomorrow to be Tuesday. So we can use these worded ways to describe probability and relative frequency. So here's a breakdown of something of what these words mean. We've added some numbers here as well. It's not set amounts, but it's just to give you a rough idea. Certain is 100% that something is happening. So the example of tomorrow is going to be Sunday. Tomorrow will be Sunday. It's 100% of that, 100% chance of that happening. Very likely is 90 to 99% of something happening. Likely is 51 to around 90. Remember, guys, these are just rounded approximations just to give you a bit of an idea. They're not exact. Even chance, well, it's 50-50, isn't it? And unlikely will be anything less than that 50% chance. And impossible, and very unlikely would be around 1 to 10%. Impossible means 0%. Okay, so ones that you should be certain of, for the numbers being exactly the way that it's been described, is certain. Certain is always 100%. Impossible is always going to be 0%, and even chance is always going to be 50%. And the rest are between them. Okay. Now, probability is normally measured on a scale to 0 to on a scale to 0 to 1. So remember, if you've calculated the probability of something and it's more than 1, you know that you've made a mistake somewhere. If it's less than 0, again, you've made a mistake somewhere. It always has to be measured between a scale from a scale of 0 to 1. 0 meaning impossible, 1 meaning certain. Okay, so remember that 0.5 in this case, that 50% would be the same as 0.5. That would be the even chance. I think that's a very important point, and I think you should all write that down. Probability is always measured from a scale to 0 to 1. So remember, even if you've got an answer as a percentage, that percentage converted into perhaps a decimal, it would be between 0 to 1. Again, if it isn't, if you've got 110%, you know you've done something wrong with your calculation. So make sure that your answer when you've got probability is between 0 to 1. Right, let's have a go at doing some questions now. I believe we've got now lots of oh yes, we've got lots of questions now. We're going to do some past paper questions and then have a go at some Slido questions based on what we've done so far. So here it says Tom has a fair spinner with 8 equal sections. He is going to spin the pointer. Draw the lines to show how likely the following are. Okay, so the first one's been done for us. He will spin the number 3. So this is the number 3. What are the chances of this happening? Well, unlikely. Why is it unlikely? Well, because we've only got one chance of that 3 coming up. However, we can see for the ones, we've got 3 lots of ones. I'll use different colours for this. We've got 1, 2, 3, 4 5s, and we've only got 1 3. So it could happen, that spinner could land on a 3. There's a chance it could happen. However, it's very unlikely in comparison to the other ones. Right, so let's have a look at the next one. He will spin the number 5. Well, the number 5 comes up on 4 different occasions. So it's not certain, it's not definitely going to be a 5 because we do have other numbers on the spinner. So we can't say 100% the spinner is going to land on a 5. But it is likely because it's the number that comes up the most often. We've got 4 5s that come up. So it's likely, but it's not certain. So we're going to match that up there. The next one says he will spin the number 6. Now, can he spin the number 6? Well, let's have a look at the spinner. We've got 1s, we've got 5s, and we've got 3s. Do we have a 6? No, we do not have a 6. So the chance that a 6 will pop up when he spins the spinner is going to be impossible. There are no 6s. There is a 0% chance it's going to land on a 6. Now, the next one says he will spin a number less than 7. 1, 2, 3, 4, 5, 6, 7, 8. Oh, actually, that could be an even chance. Oh, this could be an even chance, actually. Because that's 4 out of... This one, it could be likely or even chance. Okay, I'm going to come to that after I've done this one. He says he will spin a number less than 7. Now, why is it that he can spin a number less than 7? Well, let's have a look. What are numbers that are less than 7 on the spinner? Well, 5 is a number less than 7, and we've got 4 lots of 5s. We've got 1s that are less than 7, so that we've got another 3, and we've got 3 that are less than 7. So pretty much every single number on this spinner, not pretty much, it is, every single number on the spinner is less than 7. So the chances of getting a number that's less than 7 is going to be certain. There is a 100% chance that the number is going to be less than 7. So for that one, we can tick it off there. Now, if we go back to he will spin the number 5. Now, the reason why I have stopped there and I'm going to reconsider my answer is if I have a look at the chance of spinning the number 5, 5 comes up 4 times. But if I had to write this as a as a fraction or as a probability decimal or as a percentage, let's see if we can calculate it. I've got 1, 2, 3, 4. 4 chances out of how many different options? 1, 2, 3, 4, 5, 6, 7, 8. 50% of the chance is that it will land on a 5. So 50% chance means that there is an even chance. We know 50-50. We know 50-50 equals what? An even chance. So the chance that it will land on the spin on the number 5 is going to be an even chance. It can either land on the 5 or it can land on the 1 or the 3. So for this one, we would actually match it up with the even chance. So be very careful. Have a look at the numbers as well. That's why it's always important for when you're even looking at worded probability, perhaps write the numbers next to it as well. Write it as a relative frequency. If you write it as a relative frequency, you're able to get an idea as well as to whether you can say it's certain, likely, or unlikely. So here we go. Here are the answers that we got. The first one was done for us, and the rest were correct. Perfect. Okay, let's see if we can have a go at solving a question on Slido. True or false? I'm likely to spin a 2 as a 3. Is that true or is that false? What do we think here? We've only got 4 answers. Again, do we have 50? Yeah, we should have more than that. Give them a couple of seconds. Come on, guys. True or false? All right, let's stop there at 40. Well done to 85% of you that said true. Oh, that said true. Brilliant. Let's have a look and see why that is true. It says I'm equally likely to spin a 2 as a 3. If we have a look at 2, well, 2 we've got 1, 2, 3, 4. No, hang on, 1, 2, 3. Sorry, I thought that 3 at the bottom was 2. We've got here 3. We've got 3 out of the total that can be a 2. And we've also got 1, 2, 3 out of the total of 8 to equal 3. So they both have that relative frequency of the 3 out of 8. So that's why we say that there's equally likely chance of it being a 2 and a 3. So well done for all the 88% that got that correct. Let's have a look at the next one. I'm more likely to spin an even number than an odd number. It's been divided into 8 sections. Have a look. Where are those odd numbers? Couple more seconds. Have a look. Even numbers and odd numbers. From there, how many even? From there, how many are odd? Okay, let's stop there. Fantastic. 90% of you got that correct. 90% out of the 40. Let's have a look at this one. I'm more likely to spin an even number than an odd number. So let's have a look at the even numbers. Well, we've got 3 2s. So 3 out of the 8 would be considered an even number because 3 and 1, they're odd numbers. So 3 out of 8 are even. However, I've got 1, 2, 3, 4, 5 out of 8, which are odd. So I've got here 3 out of 5 eighths. So which one is going to be more likely? Well, it's going to be more likely to have an odd number than an even number. So that's why this question was false. Right, let's do the last one. True or false? It is impossible that I will spin a number less than 2. What do we think for this one? Is this one true or false? Okay, let's have a look at this one. Well done, 95% of you got that correct. Is it true or false? It's impossible that I will spin a number less than 2. Hang on. Yes, that is false. Why is that false? Well, because we've got 1 there, and 1 is less than 2, so it would be false. There is a chance that you can spin that and land on a 1. There is a 2 out of 8 possibility of that happening. So no, it's not impossible. It could be unlikely, but it is still possible. It still could happen. Next one, true or false? It is certain I will spin a number less than 4. Okay, let's have a look. Fantastic, 97% of you got that correct. Why is it certain? Well, any number less than 4 is going to be 3, 2, and 1. And those were the only options that we have here on the spinner. So it is 100% chance that we're going to get a number less than 4, which is the same as it being certain. We definitely will be getting a number less than 4. Brilliant. Okay. So that's exactly the questions that you had answered here. Brilliant job for answering all of those. You just got yourself 2 marks and a GCSE paper. It's a brilliant job. Well done. Let's have a go at answering the next exam paper question. So now I'm just going to look at exam questions for the topic we've covered so far. I believe there's quite a few. Double check that. Or I could be wrong. I think I'm wrong. We've only got about 2. But I believe it's on the next topic that's got a lot of questions. Okay, a bag contains 100 balls numbered 1 to 100. The balls with even numbers are black and the balls with odd numbers are white. A ball is taken from the bag at random. Match up each of these events with a chance of it happening. The first one's been done for you. So the number of the balls is odd. Well, it says here, we basically have 100 balls, okay? We've got there either being black balls or there being white balls, okay? It says here the number of the ball is odd. Well, there is an even chance of that happening because how many possible outcomes are there? Well, we know from the formula, for the probability, we're looking at the total of that probability based on the probability that we're looking for, just similar to the relative frequency. So in this case, we're looking at the chances of the ball being odd, so it being basically white. Well, it could either be odd or even, so it's going to be a 50-50 chance, isn't it, of you picking up the ball and it being odd or even. So that one we would say even. The next one said the number on the ball is 29. So they're saying out of having all of those 100 balls that you're going to pick up from the bag, the one that you're going to pick up is going to be the number 29. What is the chance of that happening? Well, the chance of that being happening, there's only going to be one 29 from the balls selected, and there are 100 totals. So if I was to write that as a as a fraction, it would be 1 out of 100. If I was to write that as a decimal, that would be the same as 0.01. What would that be in terms of me putting in a worded form? I've got impossible, unlikely, likely, and certain. Well, it's not going to be impossible because 29 could come up. There is a chance. It's not impossible. There is still a chance that that one time you pick up that ball, it could be a 29. However, 0.01 is a very small number. Yes, it is a small number. I'll describe it like that. It's a small number. Bearing in mind that we're going from 0 to 1, and I've got 0.01. So if I had it on a numbers line, it's going to be closer to 0 than it's going to be to 1. So that's basically me saying that it's not going to be possible. It's not going to be certain. It's not going to be very likely. It's going to be quite unlikely. It's not impossible. It's not 0, but it's going to be unlikely. So for this one, I'm going to match it up with this one. The next one said the ball is white. Well, again, if I've got the ball is white, what's that going to be? Same as the ball being odd. We've got here that all the, which ones are white? The odd numbers are white. So all the odd numbers are going to be white. So what is the probability that the ball is going to be white? Well, it's going to be a 50-50% chance as well, again, isn't it? So we still have a chance of that occurring. It still could be a white ball. The next one says the number on the ball is greater than 10. Well, if we've got a number that is greater than 10, well, what's that going to be? Well, a number that's going to be greater than 10 is going to be, well, it's from 1 to 100. So I know 10, it's going to be all the numbers greater than 10, which is going to be 90 out of the 100. 90 out of the 100, it's not going to be certain because there still could be a chance that we get, let's say, 1, 2, 3, 4, 5, 6, 7, 8, or 9, or even 10 when we pick up the ball. But there is a higher chance for us not to collect numbers between 1 to 10. We've got a 90 out of 100% chance of it being greater than 10. So what am I going to choose for this one? It's not going to be certain, but it is going to be likely. Okay, so that's how we would solve this question here. We've got the first one, we matched it up with unlikely. The ball is equaling white was similar to the ball is going to be odd. That's going to be 50-50. It's going to be even. And the last one is that the ball is greater than 10. That's going to be likely. So the only ones that we weren't able to highlight would have been certain and impossible. Right, so let's have a look at this question here now. This one says event A and event B are shown on a probability scale, where event A is impossible and event B is by the impossible. Complete the sentence to make them true. Event A, the ball taken from the bag is something, and event B, the ball taken from the bag is something else. What can we put in there? It's based on this question, so this is just part B of that question, where we still have the balls, you know, they've got a number of it, 1 to 100. If they're odd, and if they're even, they're a different color. I believe odd was white. Yep, odd was white, and even was black. If we have a look at event A, we've got to come up with a situation where it would be impossible. So what can we say for this one? The ball taken from the bag is greater than 100. Okay, if I said that the ball taken from the bag is greater than 100, that is going to be impossible. Why? Because if we have a look at the question here, it says the numbers are from 1 to 100. Or I could say the ball taken from the bag is green. That could also be impossible because we only have white or black balls. So that could also be another example that I could write there to say that event A is impossible because it's a different color or because the number is different from the numbers that we've got listed here. If we have a look at event B, it says here it is certain. So it's 100% chance of it it's 100%, it's certain it has to happen. Well, what could we say for event B? Well, we can say that the ball taken from the bag is going to be less than 100. That could be something that's certain because we know it's between 1 and 100. So we can accept anything here, or we could say that the bag taken for the ball is going to be either white or black. That would also be certain, 100% chance of that happening. Okay, so that's how we could solve that exam paper question there. Right, let's move on now to looking at how to write probability in a bit more sophisticated way and looking at different types of questions with probability. Now in maths, I've mentioned this before, mathematicians, we are quite lazy, aren't we? We don't like to write anything. We just like to make simpler ways of shortening words for it to mean something, to represent something. So sometimes you're going to see probability written in this way. Now we shorten the writing probability because it's quite a long word, and instead we use the word P. The P symbolizes and represents the word probability. And instead of writing what we're looking for, the probability of it being a head, the probability of it raining tomorrow, the probability of rolling a 6, we would write it something similar to this. We've got a bracket, and inside the brackets, we're looking at that probability that we're looking for. So if I said to you, what's the probability of me landing heads on a coin, I'd write the P, and in the brackets, I'm going to put the H to represent the heads. If I said the probability of it raining tomorrow, I could do probability and I say rain. The thing inside the bracket is depending on the question and what you're looking for. But the idea that you're simplifying writing probability by putting the P, and you've got the brackets, and inside the brackets you put what you're looking for. That's what I want you to help understand. Okay. Okay, so let's have a look at how we would write these in mathematical notation. So the first sentence is the probability of rolling a number higher than 2. So how would I write this? Again, we know instead of writing probability, we're going to use just the letter P and we're going to put the brackets. Now it's important to look at what we're going to write inside the brackets. It says here rolling a number higher than 3. By higher, we mean greater than 3. So inside the bracket, oh, they've put all of them there. So inside the brackets, I'm just going to put probability of a number being greater than 2. What am I going to do? I'm looking for a number. That is, oh, hang on, it's the other way around, isn't it? I'm looking for a number that's greater than 2. I'm looking for the probability of a number being greater than 2. So 2 is the smallest it can be. We're looking for the one that's going to be greater than 2. So let's have a look at the second one. The probability of picking a red bag from a red counter from the bag. So this one's going to be probability, and in the side of the bracket, I'm going to put red. You can either put R, but I'm going to put red here. The probability of it being red when we pick it out of the counter. The third one, the probability of not picking out a blue counter. Now, this is going to be something that I want you to remember because this is very, 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 very going on to high level of probability statistics, and you're going to be seeing this a lot. If you want to represent something not being, you could either draw a line on top of that probability, or you could just write down not blue as they've done here in the example. But I thought I would teach you some some advanced level statistics. And if you don't want it to occur, you put a line at the top of it. So probability of it not occurring, you can put probability of blue, and you've got to put a line at the top of it to say that you don't want that. But for this case, let's just stick to the basics. And inside you just put down not blue. The third one, the probability of rolling a 2 twice. This is interesting. How we would write this one is we would say the 2, and we would partition that to say twice using that comma. So the comma is representing how much you want that to appear, how often you want it to appear. So for example, I could have written this one, the probability of it being less than 2 the first time I've rolled it. So I can put that with a comma and mentioning that 1. However, if I want to do it on more than one occasion, so rolling it twice in this case, I'm just going to put that 2 there. It does look funny because it looks like a coordinate, doesn't it? But no, you would write it like that. Oh, and for this question, when I said you put a line on top of it, it would be like this. Probability of it not being, let's say, 5, and you put a line on top of it, and that's saying that it's not going to be that. But don't worry too much about that advanced level statistics. This one, you would just write down not blue, or not something inside the bracket. And don't be too confused about what I've just said. So that's just something really important to understand. Sometimes you've got the greater than, less than symbols inside the brackets. Sometimes you've got words inside the brackets. And sometimes you've also got the quantity of that coming up. So in this case, you're rolling a dice twice. You've got to also put them out twice in there as well. And you'll show that using the comma and the number that you wanted to come up, however many times you wanted to come up. Right, question A says, what is the probability of rolling a 6? So I've got here 1, 2, 3, 4, 5, or 6 on a standard dice. What is the probability of rolling a 6 from the dice? So again, using the same way that we've been looking at calculating probability and relative frequency, it's the same principle. We're just looking for a 6 out of those options, out of those 6 options. So 6 can only come up once. And we've got 6 possible options. So the probability of getting a 6, let's look at how I've written it. P of 6 gives us 1/6 of a chance. The probability of rolling a 2 is exactly the same amount. It's going to be the same as the probability of 6. The only thing I've done is I've written out probability of 2. The 2 is inside the bracket, but it's the exact same amount of 1/6. Remember, guys, don't be confused in thinking that I'm looking for a 6. It's going to be 6 out of 6. No, there is one chance. 1 out of the 6 chances of you landing a 6, because you could get a 3, you could get a 5, you could get a 4 when you roll that dice. There are 6 options, and that 6 only appears 1 out of those 6 times, out of those 6 options. So 1 out of those 6 options is the probability of it landing on it. All right. So the probability on a fair dice, sometimes you have dices that aren't fair, is the same for any number, and it is a 1 in a 6 chance. Remember that. C, it says here, however, what is the probability of getting an even number? All right, so now we're looking at probability of even numbers. So I'm going to write down P here, even. We're looking for all the even numbers. That's what I'm looking for. Well, out of the 1, 2, 3, 4, 5, and 6, how many are even? 1 is not even, 2 is even, 4 is even, and so is 6. So we've got 3 even numbers, 3 even options, out of the 6 total options. So probability of it being even is going to be 3 out of 6. Can I simplify that? Can you say it in a different way? Yes, I can. I can say, instead of saying 3 out of 6, I could say a half, which is the same as an even chance or a 50-50% chance. 50-50%, 50-50 or 50%, or 0.5. I've written in a worded form, a percentage, a fraction, and even a decimal. So to calculate it of it being an even number would just simply be half of it. Right, let's see if you guys can try to answer this question here. What is the probability of rolling a multiple of 3 on a normal dice? A standard dice means it's only going up to 6, okay? Remember that. I'm going to go for a break in the next 10 minutes. Okay, let's stop there. Fantastic. So let's have a look. We've got 47% to be that said a third, and 39% to be that said 1/6. Interesting. That's quite a high statistic there. Let's see how we would solve this question. Well, on a normal dice, we've got 1, 2, 3, 4, 5, 6. Out of those, well, we've got 3 is a multiple of 3, isn't it? 1 times 3 is 3. But we also have 6, which is 3 times 2. So we have 2 options there, 2 out of the 6 options. So if I was to write it as a fraction, that would be 2 out of 6. Now, the reason as to why the answer is a third is because I have to simplify that. 2 out of 6, if I simplify that fraction, would give me 1/3. 2 out of 6, finding a number that goes into both the 2 and the 6 is going to be 2. So I divide both of those by 2 and I get a third. I've simplified the fractions. Don't forget to simplify fractions, guys, okay? Don't forget to do that. Right, so well done to the 71% of you that got that correct. Let's have a go at doing some example questions now. A special dice has 8 sides with the numbers 1 to 8 on it. What is the chance of rolling a 4? So we're looking at the probability of landing a 4. Now it says here the dice has 8 sides with numbers 1 to 8 on it. Now we want just the 4. So if we want just the 4, well, if it's the numbers from 1 to 8, well, we've got 8 total opportunities, don't we? 8, hang on. Yes, 8 total options, sorry, as in 1, 2, 3, 4, 5, 6, 7, 8. And out of those 8 options, the chances of rolling a 4, well, there's only 4 comes up only 1 time. So I've only got 1 out of the 8 chance of getting that probability of a 4. Okay. Now this is where it gets, the next one's a bit more challenging. It says, what's the probability of rolling a prime number? So if I have a look at my options, I've got my 1 to 8, I've got 1, 2, 3, 4, 5, 6, 7, 8. First thing we're going to do is we're going to pick out our prime numbers, right? Well, we've got 2 as a prime number, 3 as a prime number, 5 is a prime number, 7 is a prime number. So we found our prime numbers. Now, what are the chances of getting those numbers, those prime numbers? What's the chance of getting 2 when we roll the dice? Well, we've got 1/8 of a chance. What is the chance of us getting a 3? We've got 1/8 of a chance. What's the chance of me getting that 5? It's 1/8 of a chance. What is the chance of us getting a 7? Well, it's 1/8 of a chance. So when we calculated all those total amounts, when we calculated this individual amounts for the 2, the 3, the 5, and the 7, we need to find the total probability. So what do we do now with those 1/8 that we found? We add them together. So we added the probability of getting the 2, we added the probability of getting the 3, we added the probability of getting the 5 and the 7 all together, and we got 4/8, which is the same as a half because I simplified that fraction. So sometimes you get questions that are like this as well. That's not just looking at a specific number, but perhaps a prime number or an even number, an odd number, a composite number. You get different types of questions, but you have to make sure that when you've got this, you need to add them together. You add them all together to find the total. Let's have a look at this example here. Another special dice has 6 sides with the number on. Each number also has a color: 0, 1, 1, 2, 2, and 3. And we've got the colors red, blue, and green. What is the probability of rolling a 2? So how many options do we have? Well, we've got here a special dice with 6 sides with the numbers on it. Actually, these are the numbers, right? 1, 2, 3, 4, 5, 6. Yeah, oh, sorry. These are the numbers. We've got 0, 1, 2, and 3. What's the probability of rolling a 2? Well, so how am I going to write this? I'm going to write down probability of getting a 2 is going to be 1, 2. How much is the total? Well, I've got 6 numbers. So I've got the probability of getting a 2 is going to be 2 out of 6. But how would I write that? Do I leave that my answer like that? No, I've got to simplify it, which is the same as a third because they both divide by 2. If I do 2 divided by 2, I get 1. If I do 6 divided by 2, I get 3. So my fraction would be a third. So this means that there are 2 ways to roll: probability of red, probability of blue and red. Ignore that, I don't know what that was saying. Okay, a dice with 20 sides has the numbers 1 to 20 on the sides. What is the probability of rolling a multiple of 5? a dice with 20 sides. It has the number 1 to 20 on the sides. What is the probability of rolling a multiple of 5? We'll do this question and we'll go for our break. All right, let's have a look at the answer for this one. Well done, 74% of you got that as a fifth. Why? Well, if I've got numbers 1 to 20, 5 times table, I've got 5, I've got 10, I've got 15, and I've got 20. So I've got 4 options out of those 20 that can give us a multiple of 5. So 4 out of 20. Now 4 out of 20, I'm not going to write that as 4 out of 20. No, because I can simplify it. If I can simplify it, 4 out of 20, I can divide both of them by 4. If I divide both of them by 4, I get 1/5. So fantastic to the 83% of you that got that answer correct. Right, what are we going to be doing now? We're now going to go for our quick break. Oh, hang on, was the probability of... Oh, no, I hadn't finished yet. What we're going to do now, yes, as I mentioned, we're going to go for a quick 5-minute break and we'll be back at 5 past. Use this opportunity to perhaps go grab a drink of water, take a break, and we'll come back and continue on with probability. Okay, so I'll see you back at exactly 5 minutes past.